day students. Welcome you back to the lectures on the lecture series and the course material of Transportation Engineering 2. In today's lecture, we will be looking at one of another component of railway track or a permanent way, that is ballast. In the previous lectures, we have already discussed about two of the components of a railway track, that is sleepers and rails, and their associated features like creep in rails, the wear or defects in rails, and similarly in the case of sleepers we have talked about the sleeper density of sleepers. In today's lecture, the lecture has been outlined as ballast, the functions and requirements of a ballast, the types of ballast, the design of section. In the case of the ballast, we are starting with the definition. The ballast is a layer of broken stones, gravel, muram or any other gritty material placed and packed below and around the sleepers for distributing the load from the sleepers to the formation and for providing drainage as well as giving longitudinal and lateral stability to the track. So, the definition itself is trying to define certain things. What it tries to define in the very first line is that we can have different type of material which can be used as a ballast cushion in the railway track. This ballast cushion can be made of the broken stones or the gravel or the muram or any such material which may be suitable for the provision of the ballast cushion depending on the requirements of that ballast cushion or whatever are the properties which are required so as to provide that ballast cushion. Another aspect is that where this ballast cushion is to be provided, in what form it is to be provided. Now, there are two things which needs to be done. One is that it is to be packed below or it is to be packed around the sleepers. So, there are two conditions which will be there. One is it is going to be provided below the sleepers, that is termed as the ballast cushion, and it is going to be provided on the side of the sleepers, that is termed as packing. And the reason behind providing this ballast cushion below the sleepers or on the side of the sleepers is the distribution of loads. Now, these distribution of loads has to be done in the vertical direction, and it is also to be done in the lateral direction. So, there are two types of stabilities which needs to be taken care of. One is in the vertically downward direction, another is in the lateral direction, and that is what it speaks of when it says the longitudinal and lateral stability to the track. Within this one thing which needs to be taken care of is that whatever loads are going to be distributed from the top through the ballast cushion to the formation level, the loads or the stresses should be such that they are below the load taking capacity or load bearing capacity of the formation level. At the same time, whatever material is being used in whatever compacted form, it should have good drainage properties. So, these are some of the important things which are already being outlined within the definition of ballast. Now, we look at the different functions which are provided by the ballast cushion. Very first thing is that it provides level and hard bed for sleepers. Now, as we see that this is the ballast cushion which is provided at the top of the formation level. So, it is a leveled surface which is being provided. At the top of this leveled surface, then the sleepers are placed, and once the sleepers are placed in position, then so as to maintain their position they are packed from the sides. So, that is why they are providing a level and hard bed for the sleepers. Another thing is, as soon as the sleepers are packed from the sides, they are held in position by the ballast. So, the ballast has another function is to hold the sleepers in position. Then the next function or the important function is to transfer and distribute the load to a wider area. So, in this case, because a wider amount of ballast is being provided in the case of the rail section, in the case of the sleepers, the size of the rail section or the sectional area of the rail section or the sectional area of the sleeper is already being defined, it is much lesser in size or in measure. As compared to the ballast cushion, these values are very less. So, by using a ballast cushion, what we are trying to do is to distribute the load to a wider area, so that the formation levels or the material which has been used in the formation level can be of inferior nature and still is in a position to take the loads or the stresses which are coming from the top without any deformation or settlement taking place. It should be able to provide elasticity and it provides the resilience to the track, that is another aspect. What happens in this case is, because of the type of the material which is being used and the voids being placed between those materials, there is a sort of a mutual arrangement of the particles with respect to load, and in this form whatever the loads are coming from the top, as soon as the load is being removed, because of the elasticity the track comes back towards the normal condition, and that is how it maintains its levels, and that is what is the resilience of the track is. Further, it should be able to provide longitudinal and lateral stability, that is going to be defined in terms of the amount of material which is being provided, and on the basis of that amount of material, especially the depth of the ballast cushion, the stability will be governed. So, this is one other function of the ballast. Then it should be able to, or it should provide the effective drainage. If the drainage is not there, then the life of the material which is used in the ballast or the life of the sleepers is going to be affected. So, that is why effective drainage is required. Then it should maintain the level and it should also maintain the alignment of the track. Now, this is going to be governed with respect to the other components also, because the rail is fixed to the sleeper and sleeper is seated in the ballast cushion. Therefore, finally, it is the ballast cushion which is trying to maintain, which is trying to keep the sleepers in position, and when the sleepers are in position, the rails will also remain in position, and that is how the levels of the rails as well as the alignment of the track will be maintained. So, now we come to the next aspect of ballast, that is requirements. On the basis of the functions which we have seen, that it should be able to transfer the load to a much wider area, at the same time it should maintain the longitudinal and the lateral stability and should provide the drainage to the system. There are certain requirements which needs to be taken care of. So, in the case of the requirements, so what we are looking at is a very first thing is toughness, and it should be able to resist the wear. Now, here the toughness is a property which defines the resistance to the impact. We have seen in the previous lectures, there are certain locations or certain conditions where the impact is directly being transferred to the ballast section from the rail track, like in the case of the joints. At the another time, wherever there is an impact being induced in the rail section because of the oscillations or because of any other surface irregularity at the top, then it is going to be transferred to the ballast section. Now, because the ballast section is having a little inferior characteristics as compared to the materials which have been used in the rail sections, they should be able enough to resist the wear due to all those impacts or the forces which are coming from the top. So, this is one of the requirements of the ballast. Another one is the hardness. Hardness is another property which defines the abrasive nature of the material. Now, in the case of the ballast cushion, we are using same type of material in certain depth. So, here what is happening is that as soon as the load is being applied, the material will be transferring the load from one material to the another one which is being used in this cushion through the point of contact. At this point of contact, because of the application of the load, there will be a relative movement, and due to this relative movement, the abrasion of the surfaces may take place. So, The resistance to this abrasion is defined as hardness, and the ballast should be hard enough so as to resist this type of action. Then another one is that it should be cubical or it should have the sharp edges. Now, in this case the difference here is, in the case of the shape, is that it is not spherical or it should be cubical or should have sharp edges is the reason of the load distribution phenomena or the concept which we are using. Here, as we have seen that there is a lot of material which is being used as ballast in certain depth and the load is coming from the top. Now, as soon as the load gets applied to one particle through the point of contact, this load will get distributed to all those materials, all those say stones which are contacting this particular particle on which the load is being applied. So, through this point the load is now distributed to further say 4 particles, and this keeps on increasing towards the downward side. So, unless and until there are sharp edges by which all the materials get interlocked, there will not be a cohesive mass and the load transfer capabilities will not be there. So, in this case, as soon as we have the material which are having sharp edges and by which they have a good compacted condition being achieved, the load will be distributed to a much wider area as compared to the any other material being used as a ballast. Then it should be non-porous in nature and it should be non-water absorbent. If it is taking more of the water, it is one sort of an indication of losing the strength. So, if a material takes more water, it has lesser strength. If it is taking less of water, then it is having more of a strength. So, this is another requirement of the ballast. It should be able to resist attrition. Now, when we have talked about the hardness previously, there we are talking about the condition where there may be a rubbing action which is taking place between the material and the surfaces of the say the rail section at the joint or the surfaces of the sleepers around which these material have been provided. So, in that case it is termed as abrasion, whereas there is another phenomena which is termed as attrition. Attrition is a case where the abrasion, where the rubbing is taking place between the same sort of a material, that is the material itself, like for example stones. So, if a large amount of stone is being used as a ballast cushion, then the mutual rubbing of the stone materials will create the removal of the material at the top surface of that material, and that will be termed as attrition. And we are not interested in getting the material eroded from the top surfaces of the ballast, because as soon as this material is being eroded from the top surface of the ballast, there will be a formation of the dust, and this dust will come to the top surface, that is finally it will be coming to the rail sections and it may create certain corrugations at that section. So, this is a harmful effect in the case of the ballast. Then ballast should be durable enough. The durability is in terms of its resistance to the weathering action. The ballast section in all the railway track conditions, they are lying in the open. So, they are subjective to all the weathering agencies, maybe the sun heat, maybe the wind, or maybe the pour of the water, that is the rainfall. So, in all the cases there are certain reasons, there are certain chances by which the life of this material may get reduced. So, if they are not durable enough, if they are having the mineral composition which because of certain other minerals which are coming with the say water or with the other weathering agencies react and they loses its strength, then that ballast material is not required. So, the material should be durable enough, it should have adequate resistance against weathering agencies, and that is what is durability. Further, as we have discussed before also, it should have a good drainage property. The good drainage property is required so as to remove the chances of flooding. If there are chances of flooding, then it may take the material along with it, or there are chances that slowly and slowly the material will lose its strength. In both the cases, the track will lose its strength and it is going to be harmful in terms of the stability of the track, and there are chances that there may be any mishappening may take place as soon as the heavy loads start passing over such type of sections. Further, whatever are the requirements, whatever are the characteristics which are sought for any ballast cushion or for the material which is to be used in the ballast cushion, one thing which needs to be maintained is that the material should be cheap and it should be economical. It should not happen that we are trying to get the material from a distance at which it is available and that material is having a very high strength, and then we get it from there, but at that point of a time it incurs the transportation cost at a heavy value. So, most of the time the material which is available regionally in that area or locally is to be used as a ballast material, and that is how the economy or the cheapness of the material can be maintained. Now, once we have the idea of the different type of the functions as well as the requirements of the ballast cushions, now we will be discussing the types of the ballast which can be used. The first type of ballast which can be used is the broken stone. Now, in the case of the broken stone, this is the material which is available from the crushers or from the locations where the bigger rock materials have been reduced to smaller particles. In most of the cases in Indian railways, we are using the broken stone as the ballast cushion. These are procured from hard stones like granite, quartzite, hard trap, etc. They are economical in long run, though they are costly in the initial condition, because of the other materials which are available, which may be the waste materials, but this is not a waste material. Here this have different applications where these materials can be used. That is why initially this material may have more of a value which is to be incurred, but as far as the lifespan is concerned, they have a better lifespan because of their better properties, and therefore, if you take the total lifespan of the ballast material, it is going to be more economical as compared to the rest of the type of the materials which can be used for ballast cushion. Then another type of material is sand. Sand is the type of the material which is mostly used for CI pot sleepers. As we have seen in the case of the sleepers, when we discuss the CI pot sleepers, they are the inverted pots. Now, in the case of the inverted pot, if we are using the stone ballast section, then it is very difficult to insert those stone ballast into the pot section. Whereas, if we are using the sand as the ballast cushion, then it is very easy to insert this sand, or as soon as there is a compaction from the top of the inverted CI pot sleeper, the sand by itself will start moving inside and it will lock this pot sleeper in its location. So, that is why in the case of the CI pot sleepers, it is better to use the sand as compared to the other material. Then in the case of the low density areas with the wooden sleepers or with the steel trough sleepers, the sand can be used. This is the condition where the traffic intensity is quite less or the load are lower. In these cases, we can go for the wooden sleepers or we can go for the steel trough sleepers, and there we can, instead of using a heavy material as a ballast cushion, we can go for sand material as a ballast cushion. In all these cases, the coarser sand is generally preferred instead of a finer sand, which has a tendency to move away with the weathering agencies. The coarser sand will remain intact, and at the same time it will be having a better drainage property. These sand causes excessive wear on rail top and moving parts of the rolling stock. This is one of the problems associated with the sand. In the case of the sand, as we have seen when we discussed about the wear of the rail sections too, where it was discussed with respect to the position of the wear, what we have found is that this sand particles may get attached to the top surface of the rail sections, and when the rolling stock moves at that particular section, there is a grinding effect of this material, and because of that grinding effect of the material, corrugations may get induced into the rail section. So, this is the starting of the wearing of the rail top surface. At the same time, it may also create an effect of the similar nature in the moving parts of the rolling stock. So, it is detrimental both for the rolling stock as well as for the fixed features of the permanent way or the railway track. Then another type of the ballast which can be used is a blast furnace slag. Now, this blast furnace slag or cinders, they are in generally the sort of a waste material which is coming out of the blast furnace where the other operations have taken place. So, this blast furnace slag or cinder, they can be used in specific locations, not on the normal tracks like yards or sidings. These are the locations where the movement is very low and there is a movement at a much slower speed, and due to this reason there will not be a effect by which this material will be coming into the air and will creating an effect on the top surface of the rail sections. So, this is why these are used in the yards and sidings. So, another aspect related to this one is the economy. We are trying to reduce the cost of construction of the sections. These are also used as the initial ballast in new constructions. We have discussed these situations. We have discussed the situations with respect to the concrete sleepers, and we have also discussed this situation with respect to the long welded rails or the continuous welded rails. In the case of the long welded rails or continuous welded rails, because the system has not stabilized so far. So, in the new construction cases, there are all chances of irregularities getting creeped in. So, in that condition, if we are using the good type of the material as a ballast cushion, then it may be a sort of a waste or it may sort of a loss of material as well as the money. So, in this case, first of all what we do is we use this blast furnace slag in the new construction, and as soon as it stabilizes, this is replaced by a better quality of the material as a ballast cushion. Obviously, these are available easily and they are quite cheap as compared to the other material, but they have the corrosive effect and they are harmful for steel sleepers, and at the same time they are also harmful for different fittings which are provided between rail sections and sleepers. Then another type of material which is used as ballast cushion is muram. Muram is used again as the initial ballast in new constructions, or it is also used in some locations as a sub ballast cushion. This sub ballast cushion is a condition where we are trying to increase the depth of the ballast cushion, but then instead of providing the same good quality of the material from the top to the bottom, it is being provided in two different layers, and the top layer is being provided with the higher quality of the material, whereas the sub layer is being provided with the lower quality of material like muram. So, this is how it is used. Another specific case in the case of the muram is using as a blanket material on black cotton soil. In large amount of area where the railway tracks have been provided, there is a black cotton soil available as a formation level. The problem with the black cotton soil is that as soon as it takes the moisture, it will swell out, whereas if the moisture is removed, it will come into a squeezed condition. Along with this one, there is a tendency with respect to the load taking capacity of the material. When it is having a wetness or moisture in it, then the load taking capacity of the black cotton soil is very less, whereas when there is no moisture in it, it is totally in a dry condition, then it has a very high load taking capacity. So, therefore, if this material is used as a blanket material at the top of it, then it will try to remove the water which is going to the black cotton soil by draining it towards the side, and this is how the black cotton soil can be maintained at the same level as it is there without making any fluctuations in the overall pavement structure. Then there are other types of ballast cushions which have been used, the materials which have been used at different points of time, and they can also be used if available locally in that area, like gravel, river pebbles, conker, brake ballast, etc. So, these are all different types of the ballast materials which can be used as a cushion in the railway track structure. Now, we come to the comparison of all these ballast material. The comparison of this ballast material can be made on the basis of various type of properties. As we have seen so far, the properties may relate to its strength characteristics, may relate to the drainage, or may relate to abrasion, attrition, or these physical properties likewise. So, one such property which we are going to discuss is drainage property. In the case of drainage property, in most of the cases whatever material we have already discussed as a type of the ballast cushion material, they all have quite a good drainage property available to them, and therefore, there is no problem of flooding taking place in this type of a material. Another aspect related to these is the cost at which they are available for construction. In the case of aggregates, they are going to be the costliest one as far as the materials are concerned, and that is followed by sand and then rest of the material. We have the muram is mostly available as a locally available material, where the blast furnace slag is available in those areas where the industrial activities are taking place. So, it depends on the type of the area, it depends on the distance at which the material is available, and that is going to create an effect in terms of cost. Then another comparison is that in what way we can use them, whether that is can be used as there has a suitability of using this material as a packing material on the side of the sleepers. What happens here is that as the rolling stock moves at a higher speed, there are all chances of flying of the material along with the speed, along with the moving wheels. And if this happens, that is the flying of the material happens, the material will start coming out of its location, and slowly there will be reduction in the material which is being placed on the sides of the sleepers. So, there will be loosening effect in terms of the packing of the material on the sides of the sleepers. So, this is one of a big problem in the case of those type of materials which are having a lower strength or which are having lesser weight or specific gravity. So, in those all conditions, as there is a heavy speed or heavy traction being used, there will be a suction effect by which all this material will start coming up. So, this is why it is to be taken into consideration, so that there is no reduction in the lateral strength of the track which is imparted by the packing material to the sleepers. Another point of comparison is wear. Now, this wear can be discussed in terms of two aspects. One is the wear to the material itself. This is a case related to the inherent characteristics of the material. As we have seen, there is a stone, there are muram, then blast furnace slag is there, gravels are there, then river pebbles are there. Likewise, so many materials are available which can be used. As the loads are coming from the top, if the material is of inferior quality, then it will start breaking. So, if it is started breaking, then there will be rearrangement of the particles, and there are all chances that the settlement may also take place. Further, if this is a differential phenomena which is taking place, then there are surface irregularities will be caused in whole of the railway structure or the section. So, third thing is that if this type of wearing of the material is taking place and it is getting transformed into a smaller material, then this smaller material will be suctioned by the moving rolling stock at a higher rate as compared to the other bigger materials which have been provided. So, therefore, there is a loss of material not only in terms of its strength, but in the quantity of the material also will be lost along with the suction effect. Then another aspect is that as this material further reduces to a finer particle condition, that is the dust condition, then that dust condition will be having its effect on the rail sections and the moving loads or the rolling stock which will be moving at the top of the rail section. This again we have discussed previously. Now, this is the wear of the material, and the other case, the last case which we discussed is the wear of the other material, that is the components of the railway track. So, both of the things needs to be taken care of if we are trying to provide the type of the material in different locations. Then another aspect is the stability or resilience property of the track. In all of the conditions, the resilience property of the track is available whatever material we are using, or as discussed those materials which already being discussed here. As far as the stability is concerned, the stability is going to be a little more in case of those materials which have higher strength properties as compared to the other materials. In this case, obviously, the materials like gravel, river pebble, or the stone aggregates, crushed stone aggregates which are used from different locations, they have a higher value of stability as compared to the other one. But if the compaction of the rest of the materials is also there, then they can also provide a good amount of stability. The another point of comparison is the maintenance of track. This maintenance of track is again related with the previous conditions like the wear or the drainage property or the resilience or stability effects. Heavier is the material, obviously the lesser is the maintenance requirement in that one. Then further, there are point of comparisons are suitability or unsuitability of the material of certain locations, where the material can be used for the normal track conditions or they needs to be used for the specific conditions like the yards or the shunting grounds, like so we have to look at whether all the materials can be used in all the locations or they cannot be used. As we have seen, the blast furnace slag has more of suitability in terms of use in yards or that type of sections, or therefore, they are unsuitable for the normal track conditions. Then what is the effect of the material on the quality of track? That is another aspect. In the case of the materials which have the good properties and good drainage conditions and strength characteristics, they improve upon the quality of the track, but the other materials may have some problem, and therefore, the quality of the track may not be improved by that amount. Availability and procurement is another aspect. Most of the time it is tried to procure the material from the locally available conditions, otherwise it is going to add to the transportation cost and the overall cost of construction will increase. So, it is always better that the material is available at the place where the construction is going on or within that region. Then harmful effects we have already discussed, that if it breaks down, if there is a wearing of the thing, or if there is a chemical composition in that one which may create its effect, then all such things are the harmful effects of the material. It may be talked in terms of the corrosion effect or any other the material decay due to the mineral composition and constituents of the minerals or the mineral constituents of the material being used as a ballast cushion. So, these are all the points of comparison of different materials. Now, we look at the section of the ballast cushion, and this is the rail section being shown here, and this distance is nothing but the gauge distance between these two rail sections. These rails are being placed at the top of the sleepers, and then at the bottom of the sleeper the material is being provided. At the same time, a material is provided on the side of the sleeper like this, or at this side of the sleeper like this. This side of the sleeper where the material is being provided, this is termed as ballast shoulder, where this depth up to which the ballast cushion is being provided. This material is being provided. This is termed as ballast cushion. Now, in the case of this embankment condition, this ballast cushion is having a slope of 1:5:1, whereas this thickness of ballast cushion varies depending on the type of the gauge being used. In the case of the broad gauge, it is 20 to 25 centimeter in depth, whereas in the case of meter gauge, it is 15 to 20 centimeters in depth, and for narrow gauge, it is 15 centimeters in depth. Then this is another thing related to this ballast section is what should be the minimum depth of this cushion, below which the load bearing capacity of the foundation level or load bearing capacity of the formation level will not be in a position to take the loads and it may fail. So, here in this diagram the same thing is being tried to be depicted. Here is the sleeper, at this is the point of application of the load which is coming at this sleeper, which is generally the point of center of this sleeper, and therefore, this is the center to center spacing of the sleepers, and this is the clear spacing of the sleepers. And the load dispersion is in terms of it is assumed that it makes an angle of 45 degree with the vertical. So, therefore, from the edge of the sleeper, this is the width of the sleeper, from this edge of the sleeper, the load will get distributed in this form at an angle of 45 degree from this side, whereas it will get distributed at an angle of 45 degree in this side like this. The similar is the condition which will be happening from the other sleeper side, and so we have this envelope where this is the load distribution area of this sleeper in this case, whereas this is the load distribution area of this sleeper in this case, and there is no overlapping of these load distribution areas. So, the point of contact of this distribution up to this point, this is termed as the depth. So, this is the depth of the ballast cushion which is to be found out. Now, the same thing is being shown here. This minimum depth of the ballast section can be found out as half of the difference between the sleeper spacing and the width of the sleeper. So, this is the sleeper spacing is being taken as the center to center sleeper spacing, and this is the width of the sleeper. So, if we just take the difference between these two values and make the half of that, then that is going to be the minimum depth of the ballast section which has to be provided. The same condition is being shown in this one, where the load is also being shown here, and here this is the connectivity of this sleeper with the rail section. So, the load taking capacity of this connectivity is also into consideration. Now, when we are talking about this minimum depth of the ballast cushion and there is a dispersal at 45 degrees. So, this distance is dB. At the same time, the distance between this point and this point also becomes dB, and same is the condition from the other side. Therefore, the distance between this point and this point is nothing, but it is twice of dB. So, we have this twice of dB. This is the total distance at this level, and then we have the width of the sleepers as W on this side, and we have the width of the sleeper as W on the other side. So, what we are trying to see is that in this condition, if we look at this one, this is 2 dB plus this is half of the W which will be taken into consideration as far as the sleeper spacing is concerned, and this is half of the W which will be taken in this side. So, the total distance as a sleeper spacing is nothing but 2 dB plus W. So, using this equation of S is equals to 2 dB plus W, we have found out that value, that is S minus W, and half of that is the minimum depth which is to be provided. So, that is the concept of finding out the minimum depth of the ballast section on the basis of the load distribution criteria of the loads which are coming from the top, that is from the rail sections to the bottom of the sleeper, which is also termed as the bottom of the tie bar. This is another diagram where the stresses in the ballast section has been shown, though we have discussed it previously, but as it belongs to the ballast cushion condition, we are looking at the same aspect here again. Here what is being shown is that there is this rail section and these are the sleepers which have been provided, and therefore, there is a transfer of the load P through this rail section to this sleeper and finally, to the ballast cushion which is being provided at the bottom. And this sleeper is having width as this one, and there is a length in this direction, that is just transfers to this distance. And this is the bottom of the sleeper, which is also termed as the bottom of tie. Because the sleepers are also termed as tie in the Western European conditions or in the American condition. This is another word which is being used for the sleepers. So, here we have different conditions which are happening. We have the pressure at the bottom of the tie, that is at this level, whatever the loads are coming from this one. So, how it translates into the pressure at this level, this is one thing. Another thing is, as we go down, then how this pressure is behaving, whether it is reducing, then at what way it is reducing. So, this is what is P z, the pressure at depth z. And another condition is that if you go away from the point of application, the extension of the point of application of this load P in the transverse direction, that is either this direction or this direction, then what is the behavior of this stress, and this is being termed as P x, which is the pressure at distance x from depth z, this one along the point of application of the load P. So, we can find out that these different values, the pressure at the bottom of the tie or the sleeper is given by P A is equals to the load P divided by the bearing area. Now, the bearing area is going to be the bearing area of the bottom of the tie. The bottom of the tie is having the width as W and length as L. Now, because there are two rail sections which have been provided, we assume that the one rail section will be having its effect only up to half of the rail length, up to half of this length of the sleeper. Therefore, the sectional area on which this P will be acting is W into L by 2. So, this is what is P A. So, here the P is the isolated wheel load in whatever units we are taking, say in kg, W is the width of the tie or the sleeper in meters, and L is the length of the sleeper in meters. Then there is another condition, is the pressure at depth z in centimeters below the center of tie width, and this is computed as P z is equals to 5.24 multiplied with the P A, which is being calculated previously as P divided by W into L by 2, and this value is totally divided by a value of z raised to the power 1.25. Now, here z is the depth in centimeters, as we have seen in the diagram 2, whereas the pressure at distance x in centimeters at depth z is given by P x is equals to 0.48 P A divided by z, and this is multiplied with 10 raised to the power minus 2.06 multiplied by the square of x divided by z, where z is again the depth in centimeters and x is the distance from that depth z in centimeters. P A is the same value as we have found out previously as P divided by W into L by 2. Now, we come to the specifications of the ballast. The specifications of the ballast are related to different aspects. The first one is quality. The ballast should be hard and durable. We have already seen that this is one of the important property. It should not wear out because of any physical reason and not because of the weathering reason. So, both of the things have to be taken into consideration as far as the quality is concerned. It should be free from inorganic and organic residues, inferior and harmful substances. This is another important thing which has its effect on the lifespan of the material as well as on the lifespan of the other components which have been used along with the ballast material. So, if it is inorganic in nature or organic residues are there or some other harmful substances are there, they will react with the material of the ballast and they will react with the material of the other components, and this is how they will create an effect on the lifespan of all these things. Then another aspect is the top width. Top width varies between 3350 mm to 1850 mm depending on the gauge which we are using, that is whether we are moving from broad gauge to the narrow gauge. The depth of cushion we have already seen when we have also seen the specifications of the permanent way on Indian Railways, or we have also been discussing this aspect again and again. This is depth of cushion in the case of the broad gauge or the meter gauge is defined on the basis of the classification of route under that category. So, in the case of the broad gauge we have seen there is a classification as A, B, C, D and E, whereas in the case of the meter gauge the classification was Q, R1, R2 and S type of routes. So, in the case of A and Q this depth of cushion is 300 mm as minimum. In the case of B, C and R1 route it is 250 mm, and in the case of D and R2 route it is 200 mm. For E and S route it is 150 mm. In the case of a narrow gauge the depth of cushion is 150 mm as minimum. Then another aspect is related to the physical properties of the ballast cushion. Physical properties are related to the wearing aspects of the material. In this case there is one test which is conducted so as to check out the abrasive quality of the material, that is reducing into the fine powder form due to the rubbing action of one other type of material, and this is found out by conducting the abrasion test, and this abrasion test value at the maximum can be 30%, and in some cases with prior permission taken from the authorities can be relaxed to 35%. And this 30% or 35% defines that this is the amount by which the material can be reduced to the powder form, and this is the maximum value by which it can be done. The another property related to the physical features is impact value. Impact value is related to the resistance with respect to the impact or the jerks which are coming, and because of which the wearing of the surface may take place. So, in this case the maximum value can be 20%, and again this can be relaxed to a value of 25%. Then another property is elongation and flakiness index. Elongation and flakiness index tries to define the quantity of the material which is quite long as compared to it is related to the three dimensions of the material, that is length, width and thickness. If the length is much more as compared to the thickness and the width, then it is termed as elongated material, whereas if the thickness is very less as compared to the length or the width of the material, then it is termed as flakiness material. In this case the combined value of this one or the different value of this one that is taken separately, it can be at the maximum 50% each. A specific gravity at the minimum level can be 2.65. It is one of the indirect measure of a strength. More is the specific gravity, more is the stronger is the particle. Water absorption at the maximum is 1.1%, it should not be more than this one. Then the next aspect related to ballast is for size and gradation. The size is designated as 50 mm size for the ballast, and there are three sieves which are used so as to examine this: 65 mm sieve, 40 mm sieve and 20 mm sieve. In the case of 65 mm sieves, retained on 65 mm in desired is nil, and at the maximum it is 5%. Then retained on 40 mm that should vary between 40% and 60%, and retained on 20 mm it should not less than 98% for the material which is machine crushed, whereas in case the material is hand broken, then it should not be less than 95%. So, this is the specification of the ballast. There is another specification related to the oversize of the ballast. It has to be rejected if more than 10% of the ballast remains on 65 mm sieve. Similarly, in case the retention on 40 mm sieve exceeds 70%, then also it has to be rejected. In between those values of the values being permitted and these values, if the values goes, then there is a sort of penalty which is to be imposed by the Indian Railways. Then in the case of the 20 mmC, it is 2% in machine crushed condition, 5% in manually crushed condition permitted for passing on for 20 mmC. Then another case is related to gradation is the undersize, as we have seen in the case of the oversize, the material should not be smaller in size. Here if it is to be rejected if the retention on a 40 mmC is less than 40%, or it is to be rejected if the retention on a 20 mmC is less than 98% for machine crushed ballast or 95% for hand broken ballast. Now, we come to some of the specific aspects of the ballast, some definitions, that is packing. Packing is the compacted ballast cushion which is laid below the sleepers as per the gradation, whereas there is a boxing. Boxing is a relatively loose ballast which is placed on the side of the sleepers to provide them lateral stability. So, this is two types of the conditions which are there. One is the material which is being packed and the material which is boxed between the two sleepers which are placed side by side, and from the top it is being defined by the layer of a level of rail section. Then another aspect related to ballast is screening. Now, screening of ballast is a procedure of renewing the ballast section which has got degraded. What happens is that along with time, as the ballast is being used for a longer period of time at any location, as the loads are keep on coming from the top, or there is a weathering agencies which have their role to play in the degradation of that material. This material keeps on reducing in size or it keeps on losing its strength. So, in those conditions, as a level comes where most of the material has got degraded, then it is better to renew the ballast section, so that the strength or stability of the section can be further improved and can bring back to the level at which it was there previously. Now, there are certain reasons due to which the ballast section got degraded. They are like the crushed material clogs the voids, causing drainage problem. This is one aspect. Because there is a continuous hammering action coming on from the top, the material gets reduced to the smaller sizes, and slowly it happens that the voids get clogged because of the smaller particles, and when the voids have got clogged, then the water cannot be drained out. So, if this is a thing which is happening and there is a saturation or there is a flooding of the water or the stagnation of the water or the pounding of the water on the side, then we have to go for renewal. The penetration of the ballast in the formation is another reason. Here is happens is that the loads are so heavy, or the type of the ballast which is being used is such, or it is of smaller size, that or it has reduced to the smaller size, due to which now slowly it starts getting sinking into the formation level. And when this is happening, when this penetration happens, then the surface irregularities will induce in the track. So, therefore, it is important to screen out this type of ballast. Then another aspect is the blowing away of the ballast, that is the ballast has gone blown away, or it is a suction effect of the rolling stock which is moving at the top of the rail section. This is again we have discussed. So, in all these conditions we have to go for the screening of the material. So, the material is taken from that location and it is screened in this form. So, this is a screen which is placed, the material is being taken from the location and then it is rolled over this screen, and the finer particles are coming to this side, they have got screened or sieved like this way and they are removed. Whatever material is being laid here as a retained material is to be used as a ballast and will be taken back and relaid. So, this is what is the screening process in this case. So, this is all about the ballast. What we have discussed today is the functions or the requirements of a ballast, the different type of the ballast materials which can be used for providing the cushion, so that the loads can be distributed to a wider area. And then we have discussed about the specifications and requirements, and finally, some of the definitions. In the other lectures, we will be taking up the further other aspects related to the geometrics of the permanent way. We have already covered all of the components of the permanent way. One component which is being left is the fastenings, which will also we will be taking in the subsequent lecture. We stop at this point and I say goodbye to you. Thank you.